Oh, hello. Mr. Fritz here. I'd like to help you solve this trigonometric equation. Let's see what we have here. We've got 2 minus 4 cosine of theta plus 3 cosine squared of theta equals sine squared of theta. Wow, this one's going to be interesting. When we want to solve this, we want to keep theta in between 0 and 2 pi. So let's go ahead and dive right into this. When I'm looking at this right now, I see a cosine of theta, I see a cosine squared of theta. I'm thinking, I think this might be a quadratic. But then I've got this funky sine squared of theta over here that's kind of throwing a wrench into the system. But I can handle this sine squared of theta by actually making it into something with cosine squared of theta. So if we recall the trig identity, the Pythagorean identity, sine squared of theta plus cosine squared of theta equals 1, I can rearrange this and find that sine squared of theta equals 1 minus cosine squared of theta. So what I can do then is I can not have to worry about the sine squared of theta anymore by substituting all of that in for sine squared of theta. So let's do that and then rewrite my equation. So I've got 2 minus 4 cosine of theta plus 3 cosine squared of theta, and then that's going to equal 1 minus cosine squared of theta. Next up, I think I'm going to move everything over to one side of this, since this does in fact look like a quadratic. So I'll subtract 1 from both sides, and why don't we add a cosine squared of theta to both sides. All right, so that's going to come out to be 1 minus 4 cosine of theta, and that's going to be plus 4 cosine squared of theta equals 0. And then I'm just going to rearrange this so it looks more quadratic-like. So 4 cosine squared of theta minus 4 cosine of theta plus 1 equals 0. And at this point, I'm going to factor it. And really, you can, if the cosines are throwing you off, just picture this as like a 4x squared minus 4x plus 1. So let's factor this. And I know that I'm going to have, let's see, a minus 1 and a minus 1 here. So I think this is going to come out to be a 2 cosine square, or not squared, 2 cosine of theta minus 1 times a 2 cosine of theta minus 1. Let me just check that. So that's 2 cosine, it's 4 cosine, and then minus 2 minus 2. That looks good to me. So that's how this thing factors, and I guess it actually ends up being the same factor. So I'm just going to solve one of these then, since they're both the same. And I'm going to set 2 cosine of theta minus 1 equal to 0. And I can solve for cosine, and I'll get cosine of theta equals 1/2. So at this point, I got to go back to the unit circle, and I got to think about where cosine of theta equals 1/2. So let's think about where cosine of theta equals 1/2. That's going to be right around, well, 2 spots. That's going to be right around, nope, try that again. It's going to be right around here, and it's going to be right around here. Looking for where that x coordinate is 1/2. So this looks like it's going to be a pi over 3 is the first time that happens. And then I can consider this a negative pi over 3 if I wanted to think about it like that. However, it looks like my angle is between 0 and 2 pi. So let's see, this is going to go all the way around, and if I were to find what this angle is, I can think of what 2 pi minus pi over 3 is. So that's going to be like a 6 pi over 3 minus pi over 3, so that looks like a 5 pi over 3. And because I'm just sticking between 0 and 2 pi, those are going to be my only two solutions. And there you have it.